I came here today to discuss a topic that sometimes goes unnoticed. Our ecosystem is famous for shipping fast, have a lot of new features coming all the time, but we tend to forget about the core value we are providing to the end user, security. You can have the best project ever, but it means nothing if it gets breached. My goal today is to provide you with tools and strategies that you can use to reduce the chance of this happening to your project. These slides, as you are going to see, are loaded with information. But no worries, because at the end of this talk, I will give you a website where you can access to get these slides and related content. So let's go. My name is Patricio Calderon, Application Security Engineer at Parity Technologies, with experience auditing Rust and blockchain system for years. And you can find me in social network by Patricio PCS. So the agenda today, we are going to focus in giving an answer to these 4 questions. What, why, what, how, and when to defend your project. And at the end, we are going to get some takeaways where I also going to give you this website I mentioned. So let's start from the beginning. Why defend your project? So a good indicator to understand the current state of the whole industry is the security reports made by analysis or auditing firms. The graph that you can see here is by a slow mix from May of this year. And as you can see, almost 50% of the incidents that the industry is having are related to code vulnerabilities. That's why the code that you write, the development process, is what really matters. And this comes with great loss, as you can see in the following graph from the same report, where it says that in the last 4 years, around $63 million have been stolen in assets from the Polkadot ecosystem. If you see it from a different angle, if you take a security approach in the development phase, you can reduce the cost of your parachain, of your solo chain in the future. OK, so what you can actually do, and what is the thing that you should protect in your project? This is a question with plenty of answers. I think that all of you have probably an answer for this question. But today, I bring you my view in this topic, and I present you a projection of the traditional CIA triad, integrity, availability, and confidentiality, but applied to projects in the Polkadot ecosystem, like specifically designed for like parachains or solo chains. This is what I came up with my experience in years of auditing this type of system. So the first thing that you need to care about is integrity. This is the most critical thing that you can have in a chain. What means integrity? It means that the chain states, accounts, balance, and everything related to the data on chain needs to be correct. It cannot get changed by things that shouldn't be modifying this data. After, you have availability. Availability is quite important if you have, for example, a financial product. And this means, in the context of a parachain or a solo chain, block production, block finality, RPC access, and all these type of topics. Availability is really important. But as you may know, sometimes you need to put enriched availability to conserve the integrity of your chain. So let's say, for example, you have some security checks in your runtime. They will be constantly checking that the invariants are not being broken, the critical invariants in your chain. If one breaks, but it's a critical one, sometimes you will need to cause a panic, even if this means your chain going down. Lastly, but at the same time really important, is confidentiality. This means things like private keys or secrets. You always need to keep your private keys and your secrets, well, safe. But is not as relevant in a parachain in the sense of there is less things to worry about. So you still need to care about private keys, but because all the data on-chain is public, is the last one here. So all these three topics are relevant, but the ones that have more implicancy is integrity and availability. So let's go to how and when to defend your project. To define how and when to defend your project, you can use frameworks. And in this case, I present you NIST, but applied to Polkadot SDK in the application layer. This is a framework that is commonly used in like security, and that it have a lot of academic research behind. But the one that I'm presenting today is more a friendly version that you can use to start applying more security in your project. This is composed for 5 steps: identify, protect, detect, respond, and recover. But today, because we have a limited amount of time, we are going to focus only in protect and detect. Why? Because these two are the ones that have more practical usage in the development phase. First, let's focus on how to protect from common risk. And for this, I'm introducing today a resource that you can access in the website I will give at the end of this talk, where you can find a heavily documented list of vulnerabilities, or better say, categories of vulnerabilities, like from insecure benchmarking to inconsistent error handling. You can find the description, mitigations, how to fix these issues if you are having these issues. You can also get like real case examples, like case studies of when this actually happened already in, for example, a pallet, and more information related to these vulnerabilities. After you read this theory, these vulnerabilities, you might wonder, how can I be sure that I will not commit these mistakes while developing a parachain, for example? And for this, presenting ParaThread. It's a security game that you can play where you are going to clone a repository, and you are going to be able to develop some exploits that will, for example, DDoS a parachain, or will break some invariants, and you are going to get funds, for example. This is a fun way that you can have to be sure that you are learning deeply these vulnerabilities. So let's see this in more a case study, something that could happen to you if you are developing a parachain. So Dub is a developer that, thanks to core time, is able to launch a new parachain. This parachain allows anyone to recover an account from any parachain by using XCM. How he can do this? Well, before losing his account, something that no one wants, but it can happen, he creates a recovery account by giving a list of friends. OK, all good. He published his parachain, he shared with the friends, but suddenly the chaos starts. The blog production is taking too long, so this means that the parachain is not doing anything. He goes to the code to see what can be. And by looking at the code, he remembered that sometimes you can have some runtime misconfiguration. After looking this, he realized that the maximum amount of friends that he put, 100,000, is an excessive amount. He just committed a mistake there. So he decided to lower this to stop the attacker from spamming with too many friends. OK, he thinks that this is a vulnerability, so he goes and publishes everything. But the problem continues. The problem persists. And he's conflicted. What I'm doing wrong? So he goes to see the code now. So first, start by the runtime, see that the runtime is correctly configured. And now he goes to the code. This is the create recovery account. And by checking this, he realized that because he was anxious and he created this parachain too quickly, he skipped the process of benchmarking. And when he was creating the benchmarking, he created by a small number. So this means that when someone was sending calling this string seed with one friend, it was going to be that the same processing power, or the node will think that the same processing power for 100,000. So because of this, the node will think, OK, I can put this 100,000 strings in the current block, but when it starts doing it, it takes too long, and it doesn't manage to finish. So to fix this, he just create a new benchmarking that now, instead of using a fixed number, is going to use the amount of friends. So this will dynamically calculate the weight of the string seed, or for example, how much processing power we'll use in base to how many friends the recovery account has. Now, let's go this to how to protect from internal risk. To protect from internal risk, you can have a lot of tools that you can use, developed by multiple people in the ecosystem, and also from Rust ecosystem. In this case, you have things like a static analyzer, like Clippy, that is something really basic that you can know. And you can go all the way up to things like Kusama, that some people use it as a canary relay chain. A place is the last step before going, for example, to Polkadot. When you are using these tools, when you are implementing tests, you need to be really cautious about not just implementing the happy flow or the best way that your function can work or your string seed can work. You also need to go through the edge case to try to cover the maximum amount of cases that you can see. These tools can be used to tackle a lot of the top 10s that I mentioned before. The majority of them are useful, but some of them are more useful or recommended to tackle these issues. Here we have a list that we cannot go deeply in this now, but you can check later in the website I will mention. And some example here that you can see is that, for example, reachable panics is an issue that you can tackle better with fuzzing. Why? Because fuzzing is designed to cause panic in your system. Let's see a case study. So Dub, the same developer from before, now he doesn't want these issues to happen again. He wants to be sure that unless every time that someone is calling this function, like create a new recovery account, they know it's not going to go down. So he started looking this list that I mentioned before, and he realized that to check that the node is actually working correctly, he has to do end-to-end testing. And for this, he decided to use Zombienet SDK, where he created a test case with the maximum number of friends, and after he started creating more tests to check that the node doesn't go down, as you can see here. Lastly, in the protect phase, you have protect from external risk. And for this, I'm introducing a tool that can, if you don't know it, can be really useful when you are thinking in upgrade the version of the Polkadot SDKs in your parachain, palettes, or anything that you are developing with Polkadot SDKs. How it works? Well, you just install cargo install PSVM, and you set the version. This will upgrade automatically the versions of all these huge list of crates in your cargo.ml, and you will go directly to the correct versions. Other tools that you can use is CargoBet, that is actually really useful and used by Mozilla and Google to track the audits of the crates. So with this, you can know which crate in your supply chain is being audited and by who, or which entities are trusted by, for example, Google or Mozilla. Other things that you can use is Cargo Audit. This is as simple to use as PSVM. You just install and run in your project, and it will tell you exactly which crates specifically designed for like crates that are outside the ecosystem, like Rust ecosystem, has vulnerabilities that are publicly disclosed. These tools, PSVM, CargoBet, and Cargo Audit, are useful mainly to prevent or protect from outdated crates or vulnerable crates, as it allows you to understand better your supply chain. Let's see this in a case study to go deeply in one of these tools. So Dub realized that the Polkadot runtime was recently upgraded to a new Polkadot SDK version, and he decided to upgrade. He go to the tedious activity that is called upgrading the versions of your crate. And maybe some of you have handled with some of these issues in Rust. That is when you are changing some versions and the crates tell you like, OK, I cannot work with this version. I can only work with these others. And this other crate tell you, I can work with this one, but not these other ones. And you start trying to fix these issues, and it's a never-ending task. OK, this is a mess. But Dob managed to fix it. Goes ahead, and he managed to fix all these errors, and now it compiles, and it's ready to go. But he's quite uncomfortable. It takes you so long to finish this task, and he's not sure if he actually was lucky or he did it correctly. So he go and research. He find PSVM, and in just 2 commands, he managed to install PSVM, set PSVM to 1.7.0 in his cargo.ml. This, as you can see here up, changed all the versions to the correct ones, and it's ready to go. OK, now let's go to the third state of NIST that is called Detect. And this is about monitoring. You might think monitoring your node, your networks, but it's not only that. You also need to monitor the whole ecosystem and maybe sometimes the whole industry. And how you can do this? With disclosures. So today, I'm introducing a new tool that you can use in the same website, where constantly we are going to be pushing some disclosures about, for example, if a pallet is vulnerable, or if a pallet used in certain conditions, like certain runtime configurations, will cause you some problems. You can go here and check what vulnerabilities are available. So this tool is really useful to tackle outdated crates, of course, the supply chain, but also is really useful to tackle runtime misconfiguration. Why? Because sometimes a pallet is technically working good, but if you set up in incorrect configurations, like for example, as we saw before, 100,000 friends, maybe it will give you some problems. So it's useful to tackle these 2 issues. Other tools that are useful, but more in a broad perspective, mainly to identify or when a problem can be happening, is monitoring. Here you can use Prometheus or Grafana to monitor your network. Other things that are actually really useful are trace. Some developers don't write too many logs, but I encourage you to do it, because when a problem comes, you will be really grateful with yourself in the past of putting those logs there. For this, you can use, for example, defensive asserts or defensive programming to create some tests that, for example, will panic if you are just doing a test case, but they will not panic if you are in release or you are in production. Other tool that you can use mainly to have a broad perspective of your network is telemetry. With telemetry, you can get data like how many RAM is using the nodes in your network, which version are they using, and even their location in this really nice map that you can see here from the telemetry.polkadot.io. But be careful, because the nodes could actually modify this data, and you could be looking data that is not completely true. So it's useful to have a broad perspective, but don't fully trust in all the data here. These tools are really useful to tackle multiple of these issues, but they are mainly designed to identify the root case of the issues, so you can go ahead and try to fix them. So let's see this in a case study. Dot has a parachain, as you can see, and now the parachain doesn't halt anymore. He's really happy, and as a lot of people are using his parachain, he decided to go ahead and add the best in palette to get some developers. All good. He gets some developers, he set the best in palette, but before start like vesting some tokens to the developers to pay them, he go to check the USB disclosure or open source disclosure, and he find that the best in palette has a vulnerability. When he looked this, he realized that he only had to change some configurations to make it work correctly. And after this, he goes and he managed to upload this besting package to his parachain and pay the developers. So let's go to the takeaways. After you have understand these two phases, you can go in detail and probably check all the other phases, see what tools are related to these phases. As you might have guessed for all these things, I only was able to cover two phases. Why? Because this is a complicated task, like security or securing the Polkadot ecosystem is actually a hard task, but it's a priority. It's a priority about everything else because security is the core value we are providing to the end user. And it's a duty of each parachain, each project in the system to ensure the maximum amount of security that they can. We are in a really composable and interoperable chain where we have a lot of interactions, for example, via XCM with other parachains, so you don't want to be an attack vector to your parachain friend. Here I presented some tools that you can use to help going into this tedious task that you can use in your workflows, like, for example, PSVM when you are grading tasks, when you are grading versions. And be sure to go to this website, polkadot/security.github.io, where you're going to find these slides, and you're also going to find related content, like all these tools that I mentioned today. Everyone is welcome to contribute with some new vulnerabilities. If you think that this top 10 is not correct, if you think that you could add something new, a new vulnerability, you can go ahead and put this. We also have other things like Polkadot base, where you can put vulnerabilities that are not going to be in the top 10. And we are also looking forward for anyone that have a parachain or a solo chain or any tool that is used by everyone and want to contribute with disclosures when they're having some issues. The main idea is to bring a security hub, something for the ecosystem that everyone can share and everyone can discuss about. The repository is public, so feel free to make any suggestion, any contribution. Everything is welcome. Here's the link, and thank you for listening.